Well, greetings, everybody. This is Mike Rochelle from Dallas, Texas, and I'm joined today by the CEO of CounterPoint Solutions, Rick Bemis, an old friend from way, way back. We got reconnected on LinkedIn and had such a fun time yesterday in our conversation. I said, hey, we've got to do a show and share some of the knowledge that you have, and I'd like to get to know you a little bit better and kind of catch up. So how are you doing today, Rick?
Doing well, Mike. Thanks a lot for having me on. I really appreciate the time and the ability to get out there and leverage your outreach to give our story.
Very good, very good. So you asked me yesterday kind of what I've been up to since we did, I think it was the 1G strategy at AT&T Wireless was the last project that you and I worked on together.
Yes.
More than 20 years ago. The technology was a little bit different back then, but you know, we did some extraordinary things even back then. So I put together a one-page slide that I'm going to bring up here, and it basically talks about LeadershipN, which is my brand for Mike Rochelle and Associates. I had a student who just finished a Berkshire Hathaway company LeadershipN accelerator program, who wrote this interesting feedback, and I'm like, okay, I've got to, because it's the best way to describe what I do that I've ever heard, and I didn't write it. So he basically says that this was a unique leadership program. I have facilitated strengths finders with my direct reports in the past. This program utilized the same core Clifton survey content, but added a personalized and cooperative aggregate culture strength analysis I had never seen before. The deeper discussions and holistic approach to mind, body, and spirit was a refreshing blend for leadership development and training. So, you know, for 24 years, Rick, even back when we were together at eLoyalty, I was doing the Society for Information Management's regional leadership forum, starting in 1998, did that through 2015, then did a program with the Association for Information Technology Professionals for many years. And about 2 years ago, went on my own. Finally, I'm trying to go full-time leadership development. It's been going great. I have some great customers like Mattel, Berkshire Hathaway Guard Insurance, MoneyGram, and other great brands, Corello Engineering, OrthoFix, all organizations who are led by servant leaders who are going to be speaking later this year at my Association for Information Technology Professionals Lone Star event. I'm going to switch to that. Matter of fact, Thursday, May 16th, I think by the time this comes out, this will just be a recording, but it'll be recorded on X, LinkedIn, Facebook, YouTube, and accessible on our meetup site, which is our chapter membership site. Anyway, Spin is the former EVP and CTO for almost 7 years at Mattel, Inc., where he re-platformed them twice in that time. He's really a chief innovation catalyst. I made that title up just because I think it's provocative and kind of cool, and he's that kind of a guy. He was a student of mine 23 years ago, and I've helped him at a lot of organizations kind of align his organization as he does these transformations. But he's going to speak on the importance of centering business value at the heart of digital transformation. So that'll be Thursday, May 16th, 7 p.m. online. It is free, and I think by the time anybody sees this, it'll already be recorded and available in all those different platforms I talked about. So Rick, that's kind of what I do. What I wanted to do before I ask you to go back in time to your background is just to talk a little bit high level about what you do at CounterPoint. And I think there's an interesting story behind CounterPoint itself. So if you can kind of share that, that'd be great too.
Yeah, well, you know, we're a highly experienced consulting group. We don't do body shopping in that sense. We are actually people that can set strategic direction and give direction on different types of technologies, deep technologies too. So it's not just a kind of a fluff of a architecture, but we go into deep dives around what's best value for you and what kind of technologies will support that value. I think too often we get involved in the technology and we become enamored from it in different types of things. And also too, maybe we become enamored by our relationships, and we don't see the fact that we really have an opportunity to solve problems in different spaces that help people. And that's really what it is. So one of the things that I've done here is put together 8 pillars of data orchestration, which despite any technology, these are kind of the different things that go on when people start looking about information management. We define data. No matter what, the data definition is out there, and it's done through governance, profiles, data quality, security, and the profiles are part of mastering data. Now, that term master data management has been tossed around quite a bit, and it's evolved quite a bit, and I think it's going to continue to evolve. And what's going to force that evolution of that is the data curation that's coming with the different types of data, unstructured data management. So we have on the left side of the picture structured data management, and on the right side we have unstructured data management. On the unstructured data management side, big data is a big part of that. No pun intended, but the data capture that occurs is massive. I mean, and there's no way we're going to go back through history and solve all the data curation problems and the data that's been collected. That's just that dog is gone. But what we can do is use the massive ability to store data and then look at it from a data science perspective, to look at social determinants, some of the things that you do, and see how we can create these algorithms that would support that. Now, to me, an algorithm is just algebra, right? To try and solving an unknown. Of course, that's a simple way of putting it, but it's how you do that and what you do with it in visualizations and what have you. Then what I wanted to focus on today in our discussion is a little bit about intelligent data and intelligent data and how that works in the healthcare space. And so I've kind of organized some thoughts around that and how AI helps in that. There's another aspect of that I didn't really cover in detail, and that's what I call phraseology. And it's right now one of the biggest jobs out there, or the biggest challenges for folks, is having a response engineer bring you the proper information back based on what you're trying to do. And then last is, of course, the analytics and visualization of that. So that's, kind of the foundation of information management that I've done.
And you've done this your entire career. I remember that's what you were focused on when we were doing the strategy for the strategy group at AT&T Wireless together. So a lot of fun things. So I think the focus that I'm going to have you ask after I go to your background and kind of get a little bit more about who you are and what makes you tick and that kind of stuff is the AI stuff, because I think that part of the conversation that we had yesterday is fascinating. And all of the things that you've done in your entire career, even going back to undergraduate and doing an AI capstone project or something like that, leads you to be a very seasoned person in guiding executives on how to use AI to overcome some of those things that you talked about regarding the data architecture, right? You said you're never going to really go back and fix it the way it should be. But that's okay, because we now have some tools that can help us overcome that without having to restructure it all. Yeah. Great. So we'll get back to the technical stuff and more of your executive leadership capabilities later. But Rick, what I wanted to do, as we started to do on our personal call yesterday, where were you born? Where did you come from? How did you kind of grow up into who you are? So go back to where you came from. Where was the hometown?
Well, I'm a native Californian, right? With my family, my mother was from New York. My dad was from Michigan, Lansing, Michigan. Go State. My dad was joined the Navy and came out to the Long Beach Naval Station here, which was a big naval station at the time. It's Long Beach in itself was a naval port. It actually housed before the December 7th attacks, the fleet, the Pacific Fleet that was here. It was moved Pearl Harbor and then attacked. But so there's pictures of, those guys out in the harbor here in Long Beach and what have you. Long Beach at that time, when my dad came and, met my mom, of course, and she had been kind of migrated out from New York to Florida to here. And of course, they got together and they had 6 kids. And I'm the oldest son of the 6 kids. I had a sister that was older, and then 4 other siblings beneath me, right? So we're 4 boys and 2 girls, so that was a challenge because the girls got everything. The boys kind of had to make their way. So that's what we do.
That's part of the deal.
Yeah, part of the deal. Yeah. And so from there, my father in the Navy, living in Long Beach, loved Long Beach a lot, and decided to stay. And he and my mom pulled up residence in the Navy housing over here, and then, of course, started having us as their family. So as we gone through that process of, growing up, I grew up on the west side of Long Beach, go West Siders, and went through the Long Beach school systems. But as a child, had a very, very interesting and diverse kind of childhood, growing up in a mixed neighborhood of folks, learned a lot, became really have really great relationships, and you're really aware of all kinds of situations when we have that. From there, went to Long Beach Poly High School. Go Jaguars. And so Long Beach Poly High School is a kind of a sports school. But prior to that, I was at some little junior high school called Stevens Junior High School on the west side. And I was getting ready to pick an elective for school. Coming out of elementary school, you get to pick electives back in those days. I don't know if they still do that or not. Right. And one of the elective was that I felt inside of me was just always there was music. And so, I went into the music class and said, hey, I'll do this, right? Wood shop, music class, and so on. We had 2 electives. So I started taking music, and my first bit in music was as a trumpeter, so that was back in elementary school. But when I got into the junior high and could take it as an elective, I started taking cello. Right. Mm-hmm. So cello is a smaller instrument between violin and the big thing you see behind me.
Right.
Which was great. Now, cello was fine. Romantic instrument. Love the cello.
Beautiful sound.
Beautiful sound. Yo-Yo Ma, one of the fantastic cellists of his time. There's several other ones too. Mm-hmm. Pablo Casal. But I couldn't play in the jazz band. I wanted to play in the jazz band. So halfway through,
there is no cello in jazz, is there?
Well, I mean, Dave Baker would argue with you because cellist, who played with Lionel. I think he played with Lionel Hampton, and some people I've met him a couple of times when I was growing up. He's, I think, long past, but yeah, Dave Baker was a jazz cellist. But but in those days, of course, the jazz band was more big band oriented, right? Based on the instrumentation and things. So I decided to switch over to string bass, and then just fell in love with it, And after I got done with my first initial semester, I was asked to audition for. We used to have all district orchestras here in Long Beach. Sure. Long Beach was a huge music community. A guy named Fred Ohlendorf was the kind of father of the Long Beach music program, and he was just fantastic. And so, he created music camps. Arrow Bear, which is, I think it's still operating, was a music camp here for Long Beach Unified School Districts. And, you had a chance to go there if you kind of sold chocolate bars and was able to raise the money. So that kind of culture really grew the creativity inside me at a great time in my life, right? So I was learning all this music, and of course, school was kind of mundane to me at the time. I just really wanted to go. Sure. So continued through that, got accepted into the all district orchestras and went on to that. When I got into high school, I kind of diverted a little bit after 3 years in junior high school playing the bass. I still played bass, but I went over into different forms of art, and one of them was filmmaking. So I made some films, got involved with a lot of that. We, of course, being in Southern California, had access to a lot of the producers and a lot of the different screenings. So we'd go up to Hollywood and check it all out and try and learn from that. But as I got more into college, I started doing, things like theater, and I love the theater. I loved all these different kinds of arts. But my theater thing wasn't so much acting; it was backstage organizing, being a stage manager, which
Uh-huh.
brought me close to when I started working in IT, a project manager, right? So
Right.
a stage manager would just read the script, call the cues, get everything going, make sure everything operated based on a certain play or something. So, Flowers from Algernon and all these different
Right.
plays.
Well, you see all the instruments around me, so I have a similar background, although not formal like yours. My dad was a bluegrass fiddle player, so I backed him up with guitar on that.
No.
And through college, I was in a show choir. My first job in Los Angeles was actually Pasadena at the Ambassador Auditorium.
Yeah.
I was the assistant concert manager, and got to work with Yo-Yo Ma for 2 years.
Wow.
So we presented great artists from multiple genres and things like that. So
That's
I know all about your world, and now I know why you and I got along so well. There's that shared joy and love for music. That's
Absolutely. And it is a joy. I mean, it is something throughout my career, when I got out of school, I kind of started working in high school. I started working in the shipyards with my father, right?
awesome.
And at the same time, I joined a junior college, and their music program, got a scholarship for that too, right? I mean, so I was studying music and then working at night, and then studying music during the day, spending 5-6 hours in the practice rooms, getting
Right.
back and taking all the theory classes, taking all the things I needed.
Awesome.
Probably could have gone on and maybe gone to Juilliard for that.
Yep.
That was another thing that I could have pursued.
One of
But
those diversions.
yeah, well, I mean, I just wanted to play music, and the path that I was taking was more probably towards education, which is a great thing. Music education is fantastic,
Right.
but I wanted to perform more. And so, picked up and started doing a lot of, studio work or community orchestra stuff, or opera work and stuff. And so, started playing in local symphonies here in Southern California. Garden Grove Symphony at the time. Now it's the Orange County Symphony. I played in the Cypress Pops for 20 years, and then became part of that while working in the shipyard. But then, at the shipyard, I kind of left that. I got hurt on the job, and I said, well, what am I going to do? And I got a little compensation for that, and so I decided to go back to school in computer science and engineering. And the only way I did that was because I was sitting in an orchestra, and I started asking. My mom said, well, you got a little bit of money. What do you want to do? Probably should have bought Apple, by the way. I didn't. Right?
I think your education paid off better.
Yeah. Well, but I decided to invest in myself, and went into computer science. My mom said, why don't you try computers, see what it's like? And I had so I looked at it, and I saw this engineering courses. And back in the day when I started, they didn't have real computer science departments. What they had is they had electrical engineering with a computer option. So I joined in those days, learned all the technical aspects of chip manufacturing and what have you. And I didn't know anything about mathematics or anything. So when I first decided to dive in, I went for 3 months, went to the math lab at the local junior college, and just, what is algebra? What is trigonometry? What does all this stuff mean? And then made it all the way through that, and got a minor in mathematics and a degree in computer science and engineering. And then from there, that's when I started going out into the professional world while playing music too at the same time.
So interestingly, Rick, so I've had, somewhere between 3,500 and 4,000 IT execs in my leadership classes. There are a lot of IT people who are musicians.
Absolutely.
It comes up quite often. So the linkage between mathematics and music is fairly
common.
Established or common. Yeah. But the way that it serendipitously came into your life is pretty unique, I think.
Yeah, very, very unique. And going back to the point of IT people or mathematicians or computer science and music, I mean, if you look at music and you look at mathematics has 3-dimensional spaces, X, Y, and Z. You can have multiple. Basically, that's what calculus works on, 3 dimensions. Music is 3-dimensional too, Mike. It is melody, it is harmony, and it's rhythm. And if you look at a symphony orchestra page, you can see that jumping out of you in 3 dimensions, just like X, Y, and Z. So I think that's where the correlation occurs. And I think that's where some of my success in working in the industry made things better. In other words, having a creative mind first before going into engineering, I think was a very important step in my life. In other words, that because of that creativity, I was able to go from conceptual to logical to physical, is what we normally do when we're designing or looking at systems. I was able to do the conceptual side like very easy. Yeah, just fluidly. I mean, it was really that. Most people think they're conceptualizing when actually they're just being logical, right? When they're just, thinking that, well, I might have heard this in a sidebar and now I'm going to use that, and that's my concept. It's not really, right? Conceptualization really occurs when you find a unique kind of capabilities or set of understandings that you can pull together and then realize it in some kind of logical operational view. And then go from that operational view into an actual physical derivation of that into a functional systems view, right? And once you've done all those 3 things, man, you've kind of got this licked. I don't think a lot of people can think that way, though, and I think it's a unique thing. And I think that, and not that I'm the only one, but there's a lot of people out there that are very, very good, and these are the people I think that succeed.
Absolutely. So the thing with music. You also have at least 2 other dimensions that I can think of just off the top of my head, which is the composer will write how hard or soft to play the music.
Yeah.
That's on the paper itself. And then the artist also has to feel a connection with all of the other musicians, which I think might go into a 5th dimension, right? Because it's not always just hearing, it's feeling it. You know what I mean by that. Right, I was in a 1,000-voice choir once in California when I was an undergraduate, and probably the most powerful experience I've ever had. Right, when you have that many people singing the exact same words, obviously led by a great composer, it was beautiful. Yeah, so I think that is an art part, right? So it's not just the science, because we can't necessarily describe all of those things that you are and do, but there's more to it. There's the art part.
Yeah, well, and when I was consulting a lot, and I'd still be playing symphony orchestras, I would, of course, our work would be to fly out on Monday, come back on Thursday night. A lot of times my rehearsals would be that Thursday night. So, I'd take a plane, come in and, get off the plane and just grab my bass and run to rehearsal. And I got to tell you, man, I would, to see an 80, 100-piece orchestra perform and hear the sounds coming up underneath that. I can almost feel the blood rushing from one side of my brain to the other, frankly.
Absolutely.
And it got to the point where these rehearsals, when I first started playing, rehearsals were kind of a grind. I just wanted to get to the rehearsal, get to the performance, get my check, have a good time. It's the old joke of the trumpet player. When he won the lottery, they asked, what are you going to do with the money? And he said, keep gigging until it runs out. It's these kind of mentalities around music that we have, right? Sure. So it was this thing that really allowed me. Now, in my first bit of years in getting into technology after getting a degree, I started working as a programmer. Learned a bunch of software engineering skills in college, and got a math minor. And actually, kind of my music was still always there, right? It was just always there. And I think our common friend Tom Schmidt was one that was always into music too, and he constantly sent me these beautiful pieces of music. Say, hey man, you gotta listen to this. And it was inspiring. Yeah, it was very inspiring. So yeah,
awesome. So how do you progress into your modern AI kind of stuff? So where did your career go that gave you the insights that you have regarding that, and how to deal with AI?
Well, I think it's a broader question too, right? How do we practically deal with change in technology that constantly occurs? When I first started, It was, punch cards. Okay, I'm dating myself a little bit here. Then all of a sudden, full screen editors came out, and then all of a sudden, we had integrated development environments and studios, and it just got bigger and bigger and bigger and bigger with respect to the different technologies. And the way to keep up with that is really to continue to never feel comfortable with respect to where you are when you have your technology solved. In other words, when we were in the CRM space, right?
Right.
And and that came from earlier CRM spaces. Well, that evolved into CDI, which was customer data integration at the time, and then that evolved into master data management, which was a big deal because software companies were pushing this. But all of these different changes required an ability to adapt and to look at it differently, in a sense. So it kind of like in music, when you're playing sometime, you're just like going, wow, I feel like I'm not hitting things right. I'm always in chaos, but the music comes out so beautifully, right? Mm-hmm. I mean, so that chaos is constantly in your background, but yet, you project a calm by performing just wonderfully, and so I think that's the kind of it. You just got to look at technology as this kind of constant evolving cycle. So while I was in college, there was a bit of a tragedy in my family. My brother was hit by a car, and he was a spinal cord, head trauma victim with a spinal cord problem, And so in my undergrad, my capstone, what I did was invent an architecture. A couple of architectures. One was an A to D converter for, music, right? And the other one was something to jump spinal cords, and using chaos theory for that with mathematical modeling around fractals, which was the kind of foundation for where we are today in neural network development. Right. So these kinds of mathematical models and foundations have led to the foundation, or to layers of learning and layers of things that have come to bear. Now, AI has been around since the 50s. Let's not kid ourselves.
Sure.
This is not something that just came up. So it's not something that as technologists we should be saying, oh, what a surprise, generative AI came out. No. Mathematicians have been doing this. And so I think from that perspective, you have to be able to adapt and be ready for the next state once you get to that certain point of knowledge and understanding of the current state you're in. And I think the other thing too is being able to be creative enough to put an architecture around it. And I mean a real architecture, not just a bunch of boxes that have no meaning. You have to have a real architecture that lays it down, and you must be able to take it down to an operational view of whatever you're trying to accomplish. This is the thing. I mean, that's just the thing. I mean, that's just discussion points. You're able to talk to them. And the other thing is listening. I mean, talking and listening. When you're talking, you're not listening. But so you have to listen to people. You have to be able to understand what they're trying to say to you when you're pulling these things together. And not all the time. I mean, how many times we hear, that's what I said, but it's not what I meant in our development of these systems, right? Oh, right. Wow, you said that, but how come it's not doing this? We having to be able to develop into that. And then, going back to the mathematical side of it all, I kind of really like the math. I know that's kind of sad. I came from not knowing math at all to kind of really understanding it, going through the process. Is math real now? And Bertrand Russell had a discussion around that back at the turn of the century, with philosophers is, you can't show me a 2 or a 1 or a 5. I mean, these are just concepts based on the fact that we have 10 fingers. And then computers, of course, have base 16 numbering systems. But are we really talking about a more existential thing around maybe set theory? And so this was kind of the argument back in those days. But that's all evolved now. Computing's allowed us to use this and create these different kinds of visualizations and processing points that have made our lives a lot better. I mean, I'm full on to the whole thing that I'm sure everything's a threat. I mean, when you first had a car, they didn't have rear view mirrors in them. You had to force them and create laws to make them safer. And we're going to have to do the same thing here. But the benefit is great. I mean, as far as I was concerned, my brother being able to walk again based on an AI component, which is now actually realized today, it was something that it was a dream of mine. And, now we have it. It's getting better. I still think we're very much in the infancy stages of adoption. The adoption side based on our stuff, mathematicians already know. They've already got all the different mathematical concepts, and we'll talk a little bit about that when we get into the slides, but it's there, right? So it's not so much that AI is is new to them, but is new to us. And generative AI started this process by going out and talking to it. Now, again, I mean, I think that's still, request and list, and, show different things. That's great. But until we get to more human interaction with it and more ability to kind of get better responses out of it, responses that are true, don't hallucinate, that are continually giving us the right answers at the right time based on guardrails we do, I think that'll be when it's when we're really doing well.
Yeah. So a couple of things that I want to talk about with you that we kind of started yesterday. One of them was there was a conversation that Joe Rogan was having with Konstantin Kassin, and they were talking about that the thing with AI is that it is dealing with a partial reality of the world, which is the net, right? The online world. And the online world, at some level, on both sides of the spectrum, is unhinged, right?
Oh, yes.
And it really doesn't understand what that means, right? So the example that I gave you, I do multiple analysis using it. I mean, it's a great tool. I always check the work, though, because I was trying to do something and I wanted it to categorize a list of values that I had received from a customer against another set of data. And it's just easier to use it. I mean, it's literally, you tell it what to do, it does it, and then you check it and it's done, right? Yeah. But in this particular list of about 34 values, and values are virtues in my world. So virtue is there's a good and there's a bad way of being, right, in this world. There were two words that the AI would not come back in the set. So out of the 34, I asked it, connect this list into this model, and it dropped integrity and humility. Yeah. And then I told it a different way because, I'm learning how to use it too, right? So I said it a different way. It still dropped integrity and humility. I could not get the ChatGPT 4, which is what Microsoft is using now in pilot, to place the word integrity or humility into the set or model that I was doing. So I did it manually, of course, because I'm still the master of my own destiny. But I'm curious as to why that might be. So tell me again what you told me yesterday about why. With respect to kind of feelings and things of that nature, the neural network development is very complex and it's taking time. It takes a lot of time to build that out. So when you look at all the information that gets fed into your point, people are feeding information into that neural network and it's continually to do these different types of methods, multi-layer perceptors and those types of things that might come out. What it really is looking at is that it hasn't yet quite grown, although it's massive. It hasn't quite yet grown to the point of being able to reconcile some of the intangibles that we do. And so when I look at it today, so what you've done is really built out a great neural network, right? Huge amounts of information, and you see the streaming images of that. But then what that does is create, and I'm going to be simple here, okay? I'm just going to kind of keep it level, is your large language models. And so those large language models are great, right? I mean, they've been developed over time. They're feeding from all the neural network interactions that are occurring that are, kind of like these, contextual synapses that are happening in the background, creating these language models, right? But the language models are still small. They're not as broad or big as we want to be because of the fact we haven't been able to reconcile that type of emotion. And I'm not sure we're ever going to be there. I think there's a guideline, and I forgot it off the top of my head, of 10 things that come to that computers would need to do to be cognitive. Because that's what we're talking about, right? Cognition. And so it's really artificial intelligence. And I like the term augmented intelligence. There was someone out of University of Michigan, that mentioned that one time during I think it was a consulting discussion I was listening to on that. So, what we really are trying to get to is cognition on the machine and have the machine be smart enough to do that. I'm not sure we're going to get there
in this time. Maybe
Right.
there's some other retrieval methods that can bring the data back fast enough, which is another kind of point too. Neural networks have their own data schema and their own data way of managing things at the lowest bits and bytes of their network. But when we start getting into large language models, we start using other types of programming languages that we're more familiar with, like Python and PySpark and maybe some C now, or something is going on relative to that language, right? R is a big one too. So those allow us in layers to go down to that level of finding the particular thing we have. And quite frankly, the retrieval and indexing process is just fantastic in my mind. But to get to that point where we're using a broader set of programming languages, and now, of course, ChatGPT can write my program for me. I've had it write things, grab me a file, retrieve a file for me, parse it for this, give me some code for that. Boom, I get some code. Some of the database managers today are writing its own SQL, like Databricks has a component that will write you SQL. And so you can use that against other forms of data. So, we use it for augmentation. I mean, we really today can't use it for a complete cognitive understanding of what we're trying to do, because we don't know, it doesn't know what integrity means, right? It doesn't know what values mean. These types of things are stuff that we have. And go ahead.
Well, so Socrates was the one that said, the beginning of wisdom is the definition of terms, right? So I want to kind of go back into the rabbit hole a little deeper, because you're touching on this cognition idea, right? Mm-hmm. So if I utilize a large language model, I'm basically adopting whoever put that original set of large language model indices together for their worldview, right? Mm-hmm. Well, as you see in the world today, we've got a tremendous amount of angst regarding worldview, right? There's not a single way of being that any family, I think, could agree with. Much less the industry of a global kind of information technology world. Mm-hmm. So I'll leave that there. Where would you go with that part of the conversation?
Well, look, I mean, there's a lot of influences that occur within these models, and they are just models that, frankly, I'm not sure the people who develop them know where it's going with respect to the type of things it's collecting, right? So, in medicine, we have noticed bigotry coming through in some of the responses. Mm-hmm. So in that, I think what we're looking at is, and I know this sounds counterintuitive to what I was talking about, is limited language models. Languages models that only specifically have guardrails and only attend to certain types of needs, right? And so if I'm in the healthcare industry, and we'll talk about this, I need to get a doctor. So do I need to have, I need to be able to say, well, what kind of things happen when I need a doctor? If I type into some of these things, I'm a turnip and I need knee surgery, it may not come back with me and say, well, you are a turnip, unless I give it guardrails and says turnips don't have surgeries, right? So, these types of things, this kind of rule response and guardrails and limiting the kind of to a specific operational view and functional view is really where I think we go with some of the more focused AI. But when we get back down into the broader perspective of what's going on in the neural networks, we have to continue to grow that out to be able to understand these different kinds of influence that occur. So we can look at the bigotry side of things. We can look at the influence and frankly, the hallucinations that's coming through too. I mean, you get this hallucination coming through saying that, everybody, can get the same treatment and there's no real cause to it. Or, somebody of a certain segment of the society is, lazy and welfare ridden and all this good stuff. It's just going to take that kind of discussion and pick it off the web and save it. And so, we store that in our brain and we know that, this is baloney. This is good.
Yeah.
It ain't going to do that right now. What it's going to do is collect it. It's like this huge amount of consumption, of information that it continues to do, and it's going to continue to grab. I mean, every flight has 10 million sensors that are going off tracking an aircraft. Consume that, figure that out, and then look at the booking systems and see what's going on with the booking systems and what what's going on with the aircraft flight. How can I optimize these things and be able to put together a good model for ensuring that I have proper capacity based on the aircraft that's flying and the people that want to book. So I'm not running aircraft that are 50% empty, but I'm also not supplying an aircraft that's 120% full. So you use that for those types of things by using these guardrails. But what you do is you collect all this information, right? So the guardrails are really an important part of being able to leverage it based on certain type of things for people. And that's where I think in modern day, the business side of our lives are going to have to get better at. I think right now, and these are based on the different frameworks that allow us to do certain things. So there's conversational flows that must be monitored and understood. There's train of thought, which is another big thing that's going on.
That would be attention, right? It's kind of like, what are you focused in on?
Yeah, exactly. We had these large.
Have you heard any conversations with Ian McGilchrist and Jordan Peterson by any chance?
Of course, yeah.
Yeah. So Jordan and he were talking, and I may not have the numbers exactly right, but I think they're directive. It's basically that the human body receives something like 16 million bits of input per second.
Yep.
Right into our being. So it's not just your mind; it's your whole being. You're receiving all these inputs all the time, right? Yeah. And the reason we don't go crazy is because our brain actually filters it down in attention down to 16 bits.
Absolutely.
Right? So when you're talking about fractals and all of those things, I mean, our mind, the human mind and the consciousness that we have on board, right? Not having to create or understand or any of that kind of stuff. Is probably a pretty good model for that to be, and likely where these models came from, right? As almost all our technology has. So how does that play into it as well?
Well, I think when we talk about guardrails, that's part of it. But let's go back to the perceptions of human mind and what we see, right? Even today, while we're talking, and I always do this when I stand up in front of folks and talk about AI, is that you and I are talking right now, right? And I'm focused on this discussion, and I know there's a base back here and a telescope back there, and I know I have several computer screens going on here. I'm ignoring them because we're having such a great focused conversation.
Absolutely.
So I've got guardrails to ignore that. I turn off my phone ringer. Maybe once in a while you hear a little blop or a bleep coming from it, but it has no effect on me because of the fact that I'm focused on these things. Yeah, our attention right here. Now, that's not to say that in a moment's notice, if an airplane comes and crashes in my backyard, I'm not going to jump up and do something about it, right? I mean, this is just the kind of thing.
That's an override system.
Yeah, or a door falls off, Right. And I worked for Boeing for several years, by the way, when I first came out of school as a programmer. But they're good people. I mean, they're trying to do the best. Nobody's trying to make an aircraft not fly. So
Absolutely.
And that's kind of in context of what we're talking about is that you have an attention that's focused on a particular thing that you need to get done. Playing string bass in an orchestra is surrounded by tons of people, but boy, am I just focused on my part. Right. And I need to have that part right, because if I don't, the rest of it falls apart. Right. So if I start going off into tangents and some crazy things, then the rest of you and I interacting won't happen. Right. This is an orchestration that has to happen. So I like to use these terms because of the fact that in music, in this kind of, you mentioned composition. Well, composition is a great example of focus. Composition is where we take our emotions and our different things and we put it in a place. And in music, we have this sonata allegro form, which is a certain set of 4 movements that go from allegro to presto to largo to finale, right? And so we know that we're going to get that in the music, but when we start listening to it, we can probably have things outside of the bounds of what that structure is. So we're looking at structured and unstructured information, if you ask me. And if we go back to the pillars that I put together, you see the curation on the right of big data, data capture, algorithms, curation. That is just big data. Take it all in. And then on the other side is structured data management, right? So when I start getting to people about data and AI and how it works, I like to break it into those 2 places. But I also love to do raw data ingestion. I just don't believe nowadays that transformation occurs by having people sit around and figure out structures that's from one system to the other. What I like to do is be able to capture the data completely in a big data platform with a lot of metadata, and then on the touch do the structured data management. That's why master data and big data are together there. So within the master data side, what you do have is domains, informational domains, customer, product, service, anything else too. It's an abstraction. You can do more. The only reason we have master data management for customer and products is because the software companies had tools for that, and they sold it to us. But
Right.
information from a profile development perspective could be a broad set of profiles for a business in any sense. Telcos, mediation, of their provisioning of their tool set, product development in that side too, and creating those different profiles for that. The other thing that happens is that while you're doing it, and this is a little bit of the data science and data quality and data security coming through, is you create your own syntax to that. You have your own languages supporting these types of different profiles and products. So they may not be English-like in some sense, but they are suitable to the product with respect to what you're trying to accomplish, right?
Right.
So, if I create a brain scan monitor and I put a certain kind of designation for the visualization of a problem that would occur in a worm for to be relevant to today, then you would know in that profile that might have a certain syntax and a certain taxonomy to it, which gets to how physicians operate today, is based on these different types of groupings and understanding. So taxonomy is a big one, to kind of fit all these different things. So as we work our way out in these kind of big data, master data, data science, data security, data quality, intelligent data, and governance and analytics and reporting, you go from the center of this, which is the orchestration framework, and move your way out to all of these different things. And you'll notice several points of interest within each one of these pieces, right, that have specific needs and specific design considerations when doing any one of these things, right? So that's how I kind of look at data solutions and the industrial guidance with AI.
Got it. So do you have to have all of these components to start with AI?
No.
Or how do you go about doing that, Rick? And
Yeah.
obviously we're moving into the more directive side of this. So you tell me when you want to switch slides and I'll move it for you.
Yeah, no, that's fine. I always go to data governance first. It's the fundamental pillar of that. And that's where you get together. And I have a methodology with respect to data governance, which includes 6 critical success factors and 4 frameworks. I used this with Bemis when I was there, and they kind of liked it. And so what it basically says is one of the success factors is that data is an asset, just like a table or anything else that you do, right? When you go through that asset, you want to make sure that it has value to that. The one way I align value is what happens when a piece of data is missing. Maybe it has a different connotation. So when I was with the Navy Medicine, there was one thing that you would have a hatch sensor that maybe is on a surface ship. And if it's on the level 2 of the deck, you would say, oh, well, that's going to be a problem, but I think I can still sail with that hatch being a fault. But if I'm in a submarine and I have a hatch fault, I may not want to set sail and go underwater with that, right? So there are connotations to data and its value as an asset. And that's,
and context still matters, right?
Context still matters, man. And it goes back to cognition again too, right? So governance is where I start. And then on this, at the same time, I like to do this big data capture thing, right? Raw data ingestment, capture everything, even if it's bad data. I want to know. I want to know where it came from. I want to know the time it was created. I want to know if anybody's updated or changed it. I want to know all the different alignments to that with maybe photos or visualizations or other pieces of data that align to that, right? So metadata, I do that. And with the raw data there, I'm in my designs are able to kind of index the metadata, leave the actual content down here in some other form, and then traverse through it and grab it and then pull it in as I need it. And we do that quickly. And that's kind of, some of the things I wanted to show a little bit too. Maybe on the next slide. What is that? The one maybe? Yeah. So here's a kind of way we think. So if we look at guidances. This is kind of a little bit of the military too. What the military does is they look at readiness criteria, they look at the capabilities of people, they look at the knowledge, skills, and abilities, and then they are able to go to the actual fourth dimension, which is the physician that it possibly needs for a particular type of care, a particular type of need, right? So let's look at the first readiness criteria, right? That's your fundamental semantic. And like, you can go ahead and, model data based on tables and things like that. But I think that's going to be used in a different way as we go forward with AI. What I see as data storage as being that the storage model is changing, right? The persistence model changes where data is stored. Big data is going to capture everything. Keep going. Don't stop. Make oceans of this stuff. Make planetary oceans of it if you have to. But keep grabbing the data, but be able to curate it based on a readiness criteria. So there's where our guardrails come, right? So our readiness criteria was that I have all of these trainings, I have all these ranks, I have all these people, I have all these platforms, and now I need to be able to kind of expand upon that to be ready in case an event occurs, and I need to be able to assess that. Now we do it today anyway, but to do it on the fly using AI, what I call a semantic graph model, this is graph data modeling, is the best way, because then at one slice of the data, I can do two things at the same time. I can go down and then check those two things and then expand upon that. You notice this thing is kind of opening up. If you see that the nodes have a couple other nodes and then they expand a couple of other nodes. So as I go through the readiness criteria, I see that there's a part of training that I can look at their capabilities in training. And then from training, I can see what the outcomes were with respect to their actual engagements or encounters. And then from that, I can pick the best primary care physician or physician I need for a particular operation or a particular type of care. And so this right here is the model of I think, how we think.
If I'm following this correctly, then the readiness criteria could be in any industry, it could be a different need, but the model itself works because, you have to create the data model. Well, you don't have to create the data model. The data is where the data is.
Exactly.
You just have to know where it is in order how to bring it up into the readiness need, so that you can either identify, I've got the capabilities and the skilled people to do it. I love this. So I've been talking about the difference. So in my model, I have character kind of as the core basis, right? This is from a cognitive idea about how people work. And then I have strengths as far as what people are from a personality perspective at a different level than capabilities, right? So I don't know how it would work here, but I definitely want to dig into this more. Okay, so then the fourth dimension is applying it to a situation where you need all of those things to happen. And in the healthcare model, it's pretty obvious. I have testicular cancer, and I have a particular genome situation, and all of these different things. And then the system, through all of the need of the person, or the patient, at the readiness area, it will dig through this to find the person that's best able to care for them in their area, or maybe in the world. I don't know. You tell me.
Yeah, no, you're exactly right.
Okay.
What we have is training and taxonomy. So, for example, if I need an oncologist and they need to service me for testicular cancer, so I might need. There's how many oncologists are there? There's tons of them. Right, based on what the what we call the NUCC, which is the governing body of taxonomies, have with respect to their categorizations and groups and specialties, right? Categorization specialties. So, when we get down to that point of servicing you, we might not want a surgical oncologist as opposed to a hematology oncologist, which would be someone who does, leukemia or blood cancer. Or a radiation oncologist who would do breast cancer screenings and those types of oncologists. So we want to make sure we get to the right person. So we use that in the same sense with respect to the same semantic graph modeling based on the 4 dimensions of finding you a physician for that particular piece. So we look at first the physician itself, then we look at the skill of the physician, the location of the physician, and who are the associated insurance companies with that. Right? And so from there, you can look at this from a multidimensional perspective
Right.
and not like go on to your typical provider search and see, provider
True.
directory and see oncologists, and then only see a listing of it and select one, and then only see one doctor, and then have to scroll through 50 pages of physicians.
Right.
Instead, with this model here, what we can do is splash it all up on the screen and show it to you right now and give you a count of the number of types of oncologists you might have for these different types of needs. So, and then we just trickle down from there. So you
Sure.
can go through like specialty. Do I want a special language type, right? So cultural things are important when we give healthcare too.
Absolutely.
So if you speak Spanish, or are you from Vietnam, or are you Asia, or are you from Europe, and you want to be able to speak the kind of language and have a doctor who can talk to you based on those cultural needs and understandings too. Then also to location. You don't want to send somebody in an underserved community, 20 miles away to see a physician and send them on a bus that's going to take 4 hours. Right? That's not a good thing either. So a lot of this type of understanding is really based on how we can get the right care at the right time for the right person, right? And then putting together those accelerators and using data to kind of do that, right? So
awesome.
Yeah.
Okay.
So when we're talking about how we are able to put guardrails on AI for a specific industry, what I like to do is supervised learning. Okay. And so what happens with that is that you really have to have an industry expert to come in and give you rule response for the different guardrails specific to physician. Like I mentioned earlier, I don't want to know about a turnip doing oncology. I want to know about a person doing oncology. So what is the business rule? Provider physicians must register with NPES. All doctors do. They have to because they get a particular number called an MPI. If it's an MPI.
So what is an MPEP, just for those that may not be in the healthcare industry?
Yeah, it's the National Provider Registry. For any doctor that you come in, and all physicians have to have a number that's produced by NPES, which is called the National Provider Indicator, right? Which is the MPI, right? And so that number says that, yes, you've completed medical school, you've got accreditations based on the AMA, that you're a physician, and now you can register, and now you can do business in the United States as a physician. It's not the last thing. It depends on which state you're in, because each state has their own health and human services that must license you with the AMA. So, but it is the first step. And this is what we're kind of getting to, is that how do we make sure that when we talk about these different types of things, that we can do a rule that makes sure that our guardrails are properly responding based on the AI stuff. So the rule is there an MPI number? The response is, you've completed medical training and practice for medicine. Fantastic. Do you have a specific skill? Yes, I do have a skill. And the business rule is that NUCC gives you a taxonomy assignment. And they're the kind of regulator. So, we do is we use generative AI to go through this massive amount of data to bring back a particular piece and tell us what's going on with it. But then we use our guardrails to ensure that we visualize that and send it out properly. If they don't have a specific skill, it doesn't mean that they can't practice medicine. It's just that maybe we're looking for somebody like in the underserved communities to service for street medicine, right? In this case, if you don't have it, then maybe my search is done. I don't need to go any further. But if it is, and you assign a subspecialty to that person that does not have this taxonomy, so they can have a specialty without a taxonomy registered, or they can have a taxonomy that's registered. And so as we keep going through the process of improving healthcare is a very dynamic thing too. Right. I mean, when you have these different kinds of problems that occur in people, sometimes like with COVID, there was no real direct answer to what to do, and nobody knew what to do. There was a lot of mistakes done. But the fact of the matter is that something had to be done. So what that leads to is what I have over here on the far right is another quagmire of the neural network when we talk about multi-layer perceptrons, right? So it's right here. We're looking at 2 tracks. One track is the response that there isn't a taxonomy that's associated with this, but the skill is definitely needed. I mean, I'm in California here. We have a lot of LA street people that are out there living on the streets. Their healthcare is very important to my survivability and the survivability of everybody. We don't want the petri dish going off without anything. So a new skill was brought up called street medicine. Now, that skill is not registered yet with the national body that designates taxonomies, but we report that back and they'll eventually put a taxonomy on it. But until then, the need is there, right?
Sure.
And so then we go down that path of assigned subspecialties. You're able to practice medicine. You don't have a taxonomy, but you have a need based on the care that's being delivered. On the other hand,
so Rick, there are multiple perspectives from which healthcare is done. Which is this defined from?
This is defined from mostly right here, the interaction with the encounters that occur with people. So as encounters come in, as people go to the doctor, the AMA and the CDC gets the information, influenza, COVID, and all that. And so what they try to do is they actually look to see if they can get providers to be part of this area to service that particular need, right? And so sometimes that need might be something in street medicine that doesn't have a designated skill or assignment to it, right? But is basically needed, right? So you look at CDC, Center for Disease Controls, the AMA, and it's different things. FDA too gets involved in that, Food and Drug Administration, because they're looking at, we all know that the fentanyl crisis was litigated a few years ago based on how Purdue Pharma put out their Oxycontin, and it was just a tragedy what happened with them and what they did, right? But those are the types of things that guide us through this. So the regulatory bodies say, okay, you just can't go out there and be a physician, right? The physicians used to be barbers, right? They're dentists. They used to be all kinds of different ways of physician, that they kind of developed themselves. Or I think dentists were barbers, but nonetheless, they were kind of, in that genre of service, right? So we had to regulate it. We had to be able to figure out that we needed to send people to medical school to become doctors. And we needed to also be able to register everybody who is a physician, because you just can't have somebody going out there and doing things, right?
Right. So one of the things Peterson says a lot is there needs to be an adult in the room. So it sounds like there's got to be some adult that owns these supervised learning pathways so that AI is kept in the boundaries. Is that a reasonable way of thinking about it?
Reasonable way of thinking, but it doesn't exist. Okay, there is no adult.
Okay, so that's where I'm going. So right now, each provider is going to have to create this for themselves?
Yeah.
Or each?
They do already. They do already today. The adult in the room is Health and Human Services based on the federal level and each state. The problem is that a lot of these, really can't. They're struggling to be able to put this framework in some kind of a reasonable way. We do have certain types of compliance reporting that occurs, like something like timely access, which means that I have a certain amount of physicians in a certain amount of area based on population density. Every 100,000 people should have a certain amount of physicians in their state to be able to service that 100,000 people. And that drills down from national to regional to local. Kind of our old CRM territory management type of stuff, but going into healthcare based on this, right? Now, there's lots of ways of doing this, but the guardrails for being a physician are these national bodies, and so the other thing is that we also go through credentialing of the physician, right? And so when I get an insurance company who's managing a network and also a set of members that must come in and get care, which is our model today, right? We have basically the insurance company, and then we have the network that does provisions of care. We need to kind of understand if we have enough coverage based on the people in the population to allow that insurance company to exist, and to allow them to post a doctor on their provider directory. Now, if that provider directory has a doctor that slipped by and didn't have an NPI, didn't have a specific skill, and maybe wasn't registered for that state, which would be part of another chain of thought with the American AMA board, medical board, then you're liable as an insurance company for any malpractice that might occur based on that physician. So that's a big problem too, right? So you have these risks involved with respect to being a provider. You have a risk involved with respect to providing care, and you need to manage all of that, right? And so the government sets over that, and they set guidelines not only for the insurance companies to manage the encounters and claims, but also to the physicians to make sure they're trained properly and that fraud doesn't occur in this whole system, right? Which is another thing we didn't even get to, but yeah. It's a lot of stuff here, right?
Yeah,
so I think, Yeah, so this is just kind of I wanted to be high level, with respect to how a rule response method. Now, when I did this for some of the AI that we developed for provider data management, we had over, I think we branched out to almost 150 rules before we started really getting to the point of coding. So we created this matrix. We created it based on each condition we can think of, and then we allowed generative AI to come in and help us fulfill the rest of it, augmenting our understanding about what we needed to do, right? And so now we created a bot and a visualization that supports those types of things. And this type of model doesn't have to be in healthcare. It can be in anything, like we talked about earlier. This can be in retail. This can be in aircraft bookings and things of that nature. So, I mean, it's just what it is. You want to go to the next slide, and I'll kind of,
Sure.
So what we're looking at here is supervised learning based on, decision trees. And so if we look at the whole concept, and this is something that's been out there for a long time, I like the diagram: artificial intelligence, machine learning, neural network, deep learning, right? And so that's where we get to those different points of understanding what we're trying to use. To me, the frameworks out there are it's the Wild West. I mean, so if you think about this, if you go to the next slide and we look at healthcare operations and the different data points, there we are. The physicians on the far right, the patients the physicians on the left, the patients on the right. We have healthcare operations that includes 1, 2, 3, 4, 5, and 20 different operations that have to occur, either administratively or clinically or based on interactions, right? So here we are, outpatient, ambulatory. If you look at the bottom line, if you look at the top line, we look at provider relations, contracting, credentialing, provider directory, patient encounters, claims, authorizations, pre-authorizations, case management, utilization management, which is something that I'm focused on, is utilization management and case management in a lot of the things I do. Lab results, pharmacy results. And you get the pattern, right? It's going from administration all the way through to care, right? Till we finally get to the bottom right-hand corner, which is outcome and compliance and risks, right? So there's risks not only in the fact that healthcare has to ensure that we're all not getting sick and dying, but the risks that we're providing the wrong information, the risk that there might be fraudulent activity, and so on down the line. It just continues to peel off from that. And then what that does is that with our different data pillars, pushes it up into regulatory compliance. We can now, with these different pillars, show you the compliance, timely access reporting, credentialing completion, and sharing information amongst different healthcare providers to the ultimate pinnacle. The top of that roof there is the patient, right? And that the patient care is ultimately the need for all of these different type of operational and data movements and data uses. So now you can see where the intelligence comes from, man. We need that down in the healthcare operations to be able to solve these problems. Have you scheduled your appointment, please? Right. So those kinds of things. So that's kind of the crux of my discussion today, Mike. So I think the last slide is just I don't know. Is it? The
actual.
When can we help? Yeah. When can we help?
Very cool. Yeah. So I've provided your website a couple of times. For those of you, again, remember, you can connect with us on LinkedIn. You can keep up with us from that perspective. For those of you who are interested in talking about leadership development and programs to assist your organizations in building a growth mindset that would enable them to do something as extraordinary as what Rick does, I'm happy to help with that. For those of you who are interested in understanding where placing value at the heart of digital transformation with my AITP Lone Star chapter, would love to see you there. We also have an ongoing list of great people. Matter of fact, Ed Marks, who used to be the Chief Information Officer at Texas Health Resources, he was the CIO at Cleveland Clinic and many other places. He's actually going to be speaking in June on the third Thursday at 7 p.m. as well. So, Rick, this has been a phenomenal conversation with you. I really appreciate getting to know your history a little bit better, how the music kind of formulates the orchestration of everything that you think about. I look forward to talking to you again soon, my friend.
Well, thank you, Michael. Appreciate having me come on board.
Yeah, you did a great job. I really enjoyed it. Folks, see you soon. Thanks, and bye-bye. Bye.